Yes, good day, good people. I hope everyone is fine. Here we go again, Mr. Senyange Mustafa, about a trigonometric ratio. We are proving that the trigonometric ratio on the left-hand side is equal to 3 over 2. So we are proving this part here. So the first thing that we do, we look at tan of 480. First of all, you have to say left-hand side has to be equal to the right-hand side. So this one, tan 480 comes from tan. Under the reduction formula, it comes from 360 plus 120. Then sine of 300 comes from sine of 360 minus 60 degrees. Then this one gives us a cos of 14 degrees. Then sine of a negative will always give us a sine or negative sign, so which will be 180 plus 45. Alright, so divided by this one will give us a sine of 104 comes from sine of 90, then plus 14. You see this 14 and this 14 somehow they will cancel if we get the same trigonometric ratio under the expansion. So cos of 225 is the same as cos of 180 plus a 45. Yes. We shall go ahead and look at tan of 360 plus 120. That one comes from tan of 120. Then sine of 360 is in the fourth quadrant. The 360 minus 60 is in the fourth quadrant. And we know that in the fourth quadrant, cos is positive. So we shall remain with a negative sign here. Sine of 60. Then cos of 14. And obvious, this one is going to give us a negative sign of 45. Yes, we'll go ahead by saying this one is the same as cos of 14. You see this one and this one, they're going to cancel out. And then this one will give us a negative cos of 45. So the next step, this one will cancel out with this. And we shall remain with tan of 120 is the same as tan of 60, but it is a negative tan of 60 because this gives us a 180 minus 60. You see that 120. So then multiplied by negative sign of 60, and then automatically this one is negative sign of 45. Then we divide it by a negative cos of 45. Yeah. When you try to look at these special angles, we have their special table. And their special tables are like, sorry for this, let me just clean it. Their tables there, we have the equilateral triangle, and the equilateral triangle is carrying 60, 60. And when we divide it here, it will be 30, 30. And this side we have 2, 2, 1, 1. Then we also have the one for the 45. It looks like this. It's a right angled triangle. This is 45 and this is 45. Give you 1, 1 and square root of 2. We all know where this one is coming from. Then where you see negative tan of 60s, then we have a root 3 here. So negative 60 will give us a negative square root of 3. Then negative sine 60 will give us a negative square root of 3 over 2. And a negative 45 will give us a negative square root over 2. And also it's the same as a negative cos of 45, which is negative square root of 2 over 2. This one will automatically cancel out with this one. Then you're remaining with a negative square root of 3 times negative square root of 3 over 2. This one cancel out. Negative root 3 times negative root 3, you're going to get a 3 over 2. Therefore, left hand side is equal to the right hand side. Hence proved. That's how we work upon such kind of a